Lesson 5 in Chapter 10 is all about sampling. So it says, suppose a school conducted a survey about new clubs. They cannot survey every student, so a randomly selected smaller group called a sample is chosen from the larger group or population. So today when we're talking about finding information from surveying people, if the population that we're talking about is too big or it's too hard to survey all of them, we'll use a sample of that population. So in this case, our population is everyone in the school, and the sample is going to be, we're asking a smaller group because we can't get to every student and ask them what they think. Okay? Now, the way we sample students can either be biased or unbiased. You can think of bias as something that shows favoritism or shows a preference. We tend to think of bias as not really fair, where unbiased, there is no preference shown, there is no favoritism, so that tends to be more fair. Okay? So a best sample is an unbiased sample, or one that is, 1, representative of the entire larger population, 2, selected at random or without preference, 3, large enough to provide accurate data. If a sample is too small, data accurately representing the larger population may not be available. So that would be like if from the entire school I want to know what everyone's favorite color is, and I'm saying that purple is the most voted popular color. Well, if I only ask 4 students and 2 of them say purple and the others say green and 1 says yellow, well, purple seems to be the favorite out of those 4, but that's not a good sample. That is too small to be representative of the 400 and some students that we have in this building. So, of our unbiased samples, there are 3 of them. The first one is simple random. Each item or person in a population is as likely to be chosen as any other. That's the important part. As likely to be chosen as any other. So an example is 30 students' ID numbers are randomly selected by a computer. I like to think of simple random as when teachers put names on popsicle sticks and they draw names to who will answer the question. Since everybody's name is in there, each student has the same amount of chances being chosen as anybody else. So that's a simple random. The next one's stratified random. It says the population is divided into similar non-overlapping groups, and then a simple random sample is selected from each group. So this one says a population of election districts can be separated into urban, suburban, and rural strata. This would be something like if we would separate into 6th, 7th, and 8th grade and then do a random sample based off of each grade level. That would be a stratified random sample. The last one I think is the easiest to determine, and it's a systematic random. Notice they all have random in them. Random makes things to be unbiased. But the systematic random is the items or people are selected according to a specific time or item interval. So if it says something happens every 20 minutes or every 10th customer, a lot of times it says every 8th, every 5th, every 16th, something like that tells you with an interval that it's going to be systematic random. There are also biased samples. It says a sample that is not representative of the population is a biased sample. A biased sample usually favors certain parts of the population over others. So 2 biased samples would be a convenience sample. It says includes members of the population that are easily accessed. That would be if I want to know for the entire 7th grade and I just ask my first period class something. That would be convenient for me to ask them. They already come into my room. They're all there in one group together. That's convenient. Okay? Their example is the first 10 students in the cafeteria line. So again, that's convenience because it's not at random. Maybe Mr. Webster lets his students go to lunch a little bit earlier, so they're always the first 10 people in line. It's also convenient for me to just go to the front of the line and ask those 10 people rather than asking students randomly throughout. Another one that's biased is voluntary response sample. This involves only those who want to participate or can participate. So this is examples like when you send out an email and ask people to complete the survey. It could be things like, if you want to participate, go down to the office, where it requires somebody to do something afterwards, and it's their choice whether they want to do them or not. Usually, the only people who participate in those are people who have an opinion formed on what they really want. They either really like it or they really don't like it. They have some sort of strong opinion towards it, so they're going to participate in it. Others who don't really care won't probably participate in it. So the first example says, determine the types of music type of music a concert hall's customers like best. All the people attending the country music concert are surveyed. Identify the sample as biased or unbiased, describe the type, and explain its meaning. So there's 3 things to do. Biased, unbiased, describe its type, explain your reasoning. So the first thing is, since the attendees at the country music concert probably prefer country music, the sample's biased. So here's the first answer. This sample is a convenient sample, that's the second answer, since all of the people surveyed are in one location. That's the last answer. Okay, so there's 3 different answers there. Number 1 for the got it says, to determine which passengers' carry-on bags are to be inspected, every 8th person to check in with his or her bags are inspected. Identify the sample as biased or unbiased, describe its type, explain your reasoning. So if we're thinking about our types, remember we have our 5 different types. We have convenience, voluntary response, simple random, stratified random, systematic random. So in this one, I would say that this is unbiased. And I know, since it says every 8th, that it is systematic random. That's at an interval. And I'm going to say that it's systematic random because they use a specific interval for checking bags. So we said unbiased, we said what type, and we gave our reasoning why. Once you know you find your sample, you can use a prediction to decide what you think that sample will say about the entire population then. Okay? The key part here is this. It says to make a prediction, a valid prediction, or inference about a population, the sample would need to be random and either simple, stratified, or systematic, meaning it has to be unbiased. Okay? In order to make a prediction, it has to be unbiased. If you take a biased sample, that means that it's not going to represent the larger population, so we can't make a prediction off of that for the larger population. Okay? So in example 2, it says, a pet store mailed a survey to residents to determine their favorite pets. 50 people responded, and the results are shown in the table. Is this sampling method valid? If so, how many people can you expect to choose dogs as their favorite pet in the city of 1,585 people? Explain. Since this one has that they're mailing out a survey and people have to send them back in, that's going to be a voluntary response. It's your choice whether you want to mail it back in or not, or complete the survey or not. So, since it's voluntary response, that means it's going to be biased. Remember, we cannot make a prediction if it's biased. It has to be unbiased. So it says, therefore, this sampling method will not produce an accurate and valid prediction of the total number of dogs in the city. So we cannot tell how many we would expect because it's not a good sample. The got it problem is a similar type problem. Of the 2,000 watches made, the manufacturer tests for the first 15 watches produced to see if they have defects. Of the watches, 3 were defective. Is this sampling method valid? If so, how many of the 2,000 are defective? Well, in this case, since we're only doing the first 15, that's going to be biased in its convenience. It's convenient to just take the first 15 rather than doing them randomly throughout the entire set. So this is what I have. No, it's biased. It's a convenience sample because it only samples the first 15 watches. A greater or lesser number of watches could be defective later on in the batch. This is kind of the important part that people tend to forget. This is not representative, so it would not produce a valid prediction. Okay, we want to say it's going to be invalid, not unvalid, invalid, because it doesn't represent the larger population. Here's some where it actually does represent the population, so we can make a prediction. It says, from a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip at random for defects and found that 2 were defective. Is the sampling method valid? If so, how many of the 7,500 computer chips can you expect to be defective? When we're going through this, since it's every 150th chip, that's systematic random. Systematic random means that it's going to be unbiased. If it's unbiased, that creates a valid prediction. If it is biased, that will be invalid. Okay? Unbiased means that there's no preference to it. It's randomly done, so we should get a valid prediction for the entire population. Bias means there's some favoritism, preference showed, so it's going to be swayed one way. That's not going to give us a valid prediction. We say that's invalid. Okay? Since this one is unbiased and valid, we can actually figure out what we would expect for the entire thing. And they did it a couple different ways. So we know that 2 were defective, and when I asked in class, a lot of students tried to tell me it was out of 150, but it's not out of 150. That's how many went by before the next one was chosen. So if we had 7,500 and every 150th was chosen, that means there were 50 total that were looked at. So we had 2 out of 50. There's 2 different ways you can use this information. You can set up a proportion and say, well, there was 2 out of 50. I want the number to be out of 7,500. And do our cross product. So 2 times 7,500 is 15,000. 50 times x is 50x. Divide both sides by the coefficient and get your answer of 300. Or you could take your 2 over 50 and change it to a decimal. 2 divided by 50 is 0.4. That means 4%. I'm sorry, 0.04. That means it's 4%. And if I want 4% of the entire population, I'd say 4% times that 7,500. that would still get me that 300 amount. Okay, so you can do it any way that really makes most sense to you, but you want to be thinking through how you would do that problem based off of how many were defective out of how many were sampled. So you will have to figure out that there were 50 total that were sampled here. So the next one says, after finishing their meal, every 5th person that left a restaurant was surveyed. Already, since it says every 5th person, we know this will be valid because it's unbiased and it is systematic random. Okay? So, since it's unbiased, we can have a valid sampling method, and that means we can make our prediction. So it says, out of 20 people, 12 said yes, that they had dessert. What would we expect for 100 people? Well, if we have 12 people out of 20 that said yes, we want to know how many said yes out of 100. Again, you can do your cross products, or I know really quickly that 20 times 5 gives me 100. So 12 times 5 would give me that x is equal to 60. 60 people out of 100 is how many we would expect to say yes, they had dessert. There's one more I want to look at. That's in the guided practice. It says, the theater group took a survey about the type of popcorn they should sell during plays. They randomly survey 52 students at lunch. Now, they did not give us very much information here. The key part is they said randomly. Okay? So since it says randomly, we're going to kind of just assume that it's either a simple random or a stratified random or a systematic random. We don't know how they did it. We just know that they randomly surveyed. Since it was randomly done, we're going to say that it is unbiased, which makes it valid. Since it's valid, we can come up with our prediction. So of the 52 students that were surveyed, here's the data that they collected. We want to know if they're going to order 600 boxes, how many should be caramel? Well, it was 13 out of, they said, 52. So I want to know how many out of 600. Again, we could change this to a decimal and multiply by 600. We could say, okay, 52 to 600, what would I multiply by? Or do your cross products. 52 times x is 52x. And 13 times 600 would be 7,800. Divide by my coefficient on both sides. And that would mean we'd want 150 boxes of caramel popcorn. Okay? If you have any questions, make sure you're asking, and I'd love to help.